Welcome to this tutorial video. Today we'll be looking at smoothing, in particular 3-point moving average. Now smoothing is a technique used to remove the variation or fluctuation of graph data. So in this particular example we have the number of births per month at a country hospital over a calendar year. So in January we had 10 births, February 12 births, right down to December we have 15 births. That data we can represent in a calculator, as I put in here in my TI Inspire. You can see here the only difference is instead of having January, February, March, April, I put in a time code 1, 2, 3, 4, where 1 represents January, 2 represents February, all the way down to 12 represents December. So all the data is put in there, with the exception that the months are now being represented by a time code. This is what our data looks like. We can also plot that very simply. Do a plot, number of births on the vertical axes, the months on the horizontal axes, and there's our particular scatter plot. You can see here there's great variation from the top of 22 births right down to our bottom of 5. A lot of variation in our data. So we'd like to smooth that and see if we can kind of predict a linear trend, whether it's an upwards trend or a downwards trend. So we're using a technique called 3-point moving average, whereby we take the first 3 points, 10, 12 and 6, and we work out the average and we move that against the centered, so January, February and March for the 3 months, so we center that against February. The next 3 for Feb, March and April, we work out the average of 7.7 and that's moved and centered against March, the central month. Then March, April, May, we work out the 6, 5, 22 average divided by 3 gives me 11 and so forth. And we work that out for all our values. You'll notice that using a 3-point moving average, we effectively lose our data for January because we don't know the month before, and we move our data for December because we don't know any data of the month after. Let's have a look at that on our CAS calculator. So we can call it 3-point moving average. Okay, so at our first point here, we have sum of the first 3 months, and we're going to divide that by 3. So there we go. The average of the first 3 is 9.33. Now, from memory, that's exactly the same as in our PowerPoint, 9.33. The reason we bother doing that as a cell equation is we can now move that down. So what was the sum of B1 to B3? B1, which is 10, all the way down to B3, which is 6. We move that down one cell, it becomes B2 to B4, these 3, and B3 to B5, these 2 plus 1 more here. So using cell referencing is a good way to do calculations quickly. Again, we can do this. We don't need anything to the 12th. A quick way to block that out is just to use this particular button, the underscore. It allows us then to graph. Okay, so there's our data put in, a 3-point moving average. Next, we go back to our PowerPoint. We can show you what that looks graphically. So we can see that our time codes 1, 2, 3 representing the months. This is our original births for each month, the blue graph. And now our smooth, where we lose our first point and our last point because it's a 3-point moving smooth. We can see here that it's reduced the amount of variation. It's not perfectly linear, but it has reduced these extreme values of 22 and 5. On the CAS, let's see what that looks like as a graph. You want to add an extra, rather, if I click on this, click again, add a Y variable, put in my 3-point moving average. You can see here I've got my blue data, my original blue data, and now I've got my smooth 3-point moving average with the orange data. Let's go back here and I'll put in my 3-point moving average. We can now, using our menu option, analyze. We can do a regression line of best fit with a y equals a plus bx, and there's our equation for our smooth data, 11.494, take away plus a negative 0.0505x, and that's in fact what we get with our linear regression line here, exactly the same equation. Y, the number of births, is equal to negative negative 0.0505 times the number of months plus 11.495. Exactly the same. We can also compare that to our original birth data. There's the original linear regression equation. Let's now have a look at this one again. Again, number of births with a 3-point moving average is 11.4949. Take away 0.050505 times the number of months. This is how we perform a 3-point moving average.